we will start about the instruction set that are related with the addition, subtraction, multiplication and division. There we can see that the use of this B register will come later on. Okay, so coming to the first one, that addition operation, you can see that addition, add a comma hash n, that means add the immediate the data with the content of a register and put the result in a. Now if we take the example, add a comma hash 78h, okay, suppose. So after this instruction, so before the instruction, the content of a register, suppose this was 3fh, okay, and the 78h data is to be added up with this 3fh that has been stored into the a register. So after the instruction, 3f and 78, that will be added up. F means 15, so 15, 8, 23. So 23 is greater than 16. Okay, just do it like this. So 7 will come here, 1 will come here as a carry. So 7 3 is 10, 1 11, that means B. So the result will be B7H, and the B7H data that will be stored into the A register. Clear? Clear or not?
Yes, sir.
Clear.
Okay. So similarly, this the second instruction, that is add a comma R5. Suppose R5. So
So you have discussed this earlier class.
yes.
So you have discussed this in earlier class.
So addition has been discussed. So this has been.
Yes, sir.
This portion has been discussed.
Yes, sir.
Okay. Subtraction.
Yes, sir.
Subtraction has not been discussed, I think. Anyone? Hello?
Yes, sir. Subtraction we have not discussed.
Okay. So from addition, the addition has been discussed, right?
Yes, sir.
Okay. So, okay, no issues. So we are just going to the subtraction operation. Okay. So in the subtraction operation, just look into this. This particular subtraction operation cannot be done without the carry flag. Okay, just see the first example. The mnemonic is sub b a comma hash n. Okay, that means whatever the operation in the subtraction operation, that will include the content of the carry flag. Now how? Now for example, sub b a comma hash 45h 45h. Okay, so before the instruction, the content of the A register, suppose it was 79h, okay, and the content of the carry flag is 0. So after the instruction of this sub b a comma 45h, so 79h 45h 0h, okay, so this will be minus and this will be minus. Okay, This will be subtracted from 79H. These total. Clear? So that will come like 34H. So this 34H result that will be stored into the A register. Okay. And the content of the carry flag that will not be affected because there is no carry or borrow occurring. Clear? But in case of suppose take another example, sub b a comma hash 45h, but before the instruction, if the content of a register is 1fh, okay, and carry flag is 0, okay, so after the instruction what will be there? 1fh 45h and 0h, okay, the carry flag, the content of the carry flag. So it will be coming like a h, and here you can see some borrow is occurring. Clear or not?
Yes, sir.
Yes, sir.
Okay, so what borrow will be there? So in decimal numbers we are taking 1 as a carry, okay, but here 16 will be added up, sorry, 15 will be added up because the maximum number is f. So 15 plus 1 16, that is 12, the result is 12. So 12 means C. Clear? And as this 15 is there, so the carry flag will be set to 1. Clear or not?
Yes.
Yes, sir. Yes, sir. Clear, sir.
As because this is the hexadecimal number system, so we are taking 15, okay, as this is the hexadecimal number. Clear? You can remember in decimal number we are putting 10, okay, we are putting 10 as a carry, right? So here also, the after the instruction, the content of a register that will be CAH, and the carry flag will be affected and that will be set by 1. Clear?
Yes, sir.
Okay, so similar things are happening. Similar things are happening when this sub b a comma address is there. That sub b a comma 78h, okay. So before the instruction, if the content of a register, that is A3H, okay, and 78H memory location that contains 32H, okay, then after the instruction what will happen? So from A3 32 and the carry flag content is suppose 1, okay, so here the 1 will be deducted, subtracted. Clear or not? This total portion will be subtracted. Clear?
Sir, sir,
Yes.
sir, this is right.
Aditya, your voice is breaking. Can you please repeat? Or you can write in the chat box.
Sir, sir, this, sir, it has to H.
I cannot hear because your network, I think, that is not proper.
Yes, sir.
You can write in the chat box so that I can I will be able to know that what are you talking about. Okay, so this will be 0, and there will no case of carry or borrow. So this will be 70H. Okay. Yes, from Aditya sir, this 78H is the memory location of hexadecimal number of number 32H. Yes, because we are just look into this. We are discussing about this example. Look into the PPT. Okay. So here this address, that means the content of the particular address that will be subtracted from the A register. Clear? So that
Yes, sir.
here 78H memory location that will hold the value of 32H, and this 32H will be subtracted from the A register. Clear? Now coming to the third one, that's sub B A comma RR, the same operation is going on. The content of the A register and the content of the carry flag and the content of the RR register. Okay. So the RR register, the content of the RR register, suppose this is okay, let us complete this one, otherwise we'll forget. Okay. So this one is the sub B A comma R5. Suppose R5. Okay. Now sub B A comma R5, that before the instruction, if the content of A register, that is 79H, okay, and the content of R5, that is 34H, and the content of carry flag is 0, okay, then after the instruction what will happen? So 79H, 34H, 0H, this total thing will be subtracted from this 79H. Okay, so this will be 5 and this will be 4. So this 45H, this will be stored into the A register. Okay, and the content of R5, this will be unchanged, no carry is occurred, so carry flag will also be 0. Clear or not? Any questions?
So the content of R5 constant after instruction.
Yes, the content 5, here the content of 78H memory location, here the R5 content, and the fourth one, the content of RP register, that will not be changed. Only the change will occur in the A register and the carry flag. Okay.
Okay, sir.
Okay. So this is the very important instruction, as because there is a instruction that includes the B register. So at the very beginning of this semester classes of this particular subject, we have discussed that the B register is only used for the multiplication and division operation. Okay. So here is how, just see, this multiply A by B, put the lower byte of the product in A, put the higher byte of the product in B. So for simplicity, okay, we are taking for example MULAB. Okay, so before the instruction, if A register contains A5H and B register contained 5AH. Okay. So after the instruction, what will be there? Now, for example, for simplicity, because the multiplication will take some time. So we are just taking as XXYYH. Okay. So this is the result of this particular 8-bit multiplication operation. Okay. So this is the lower bit. Okay. And this is the higher byte. This is the lower byte. This is the higher byte. So this, after the instruction, what will be the content of A register? Tell me.
Sir, the higher byte.
A register will be?
The higher bits.
No. Into the PPT.
Sir, why?
So the lower byte, very good. The lower byte will be stored into the A register and the higher byte will be stored into the B register. Clear?
Yes, sir.
So just for the next one, this is the division A comma AB, div AB, that is before the instruction. If the A register contains EEH and B register contained 11H, so after the instruction, now just see that EEH divided by 11H. Okay, and suppose the result is PPQQ. Okay, PPQQ, that means just like that, the quotient is PP and the remainder, that is QQ. Okay, so after the instruction, what will be the content of A register?
PPH.
Very good. That is a quotient will be stored into the A register, that will be PH, and B register, that will be QQH. Clear or not?
Yes, sir.
Okay.
Yes, sir.
So just look into the note. This is very important one. In multiplication and division operation, carry flag is always set to 0 and overflow flag, that will be set. This is the very important one. Okay. So coming to the jump and call instruction, if we can remember, we have discussed about those jump instructions in case of push and pop operation, because these jump operations includes the operation of the stack. Okay, now how is it possible? Now for example, we are taking as, suppose the program is running on 8000H. So this way the program flow will be there by this way. Suppose there is a, in this 80A3 memory location, there is some jump operation. Okay, so what will be there? So jump operation means it will not go to the next memory location. Otherwise, this jump operation takes the program to another memory location which is not the consecutive memory location. That means this memory location, after this memory location, some memory location will be there in the program counter. The program counter content that will be removed, and the new memory location, suppose jump operation tells that the program will jump to 9000H. Okay, so some in 9000H, some program is there from 9000H to suppose 90AH. Okay, so after executing this program, this particular program counter content will come back to this next location. Clear? So how the operation is going on? So the program counter value of just after this jump operation, the program counter value will be set by this 9000H. Clear? And the previous content of this program counter, that will be automatically go onto the stack pointer. Okay, that will be pushed into the top of the stack automatically. We need not to give any instruction. So that is the jump operation. Through this jump operation, the program counter and stack pointer, these two registers comes into play. Is it clear?
Sir, can you please repeat it?
Okay. Now just see. Now just see. Some program is going on from 8000H. Okay. Some program is going on. So after coming, suppose on 80A3H, some jump operation is there. Okay. So by this jump operation, suppose this operation says that the program needs to be taken from 9000H memory location. Okay. So the program counter content during this particular programming, that was 80A4, the next memory location to be executed. But whenever this instruction is executed, this 80A4 memory location will not be there, because the program says that अभी हमको ये 9000H memory location से program execute करना है, right? So this 9000H will come to this program counter. Okay. So, and suppose from 9000H, some program is going on up to 90AH. Some program is there. So after completion of this program, execution of this program, this will come to this particular main program. Okay. This is the main program. So if after the completion of the execution of this particular programming that is written from 9000H to 90AH, if this needs to be back into the, just a minute. So if this needs to back into the main program, so main program contain this 80A4, which was nothing but the next memory location to be executed in the main program, where this address will be stored, because after the completion of this program, the program counter needs to load the main program content from the next memory location. So the program counter will not understand that, how it can store, how the program counter can store this particular data, this particular address actually. ना जब भी ये jump operation execute होता है, automatically the present program counter content 80A4 that will be stored into the top of the stack. Okay, this is the stack. So here the 8014 data was stored. So after the completion of the program counter tells that acha hum khali ho gaye, now send me back those data. So the program counter will be loaded by this 80A4 data, sorry 80A4 data. Okay, so by this way the stack pointer and the program counter operates during this jump operation. Is it clear or not?
Yes, sir.
Okay, so now this there are jump instructions that are divided into three categories. Okay, so if this kind of operation JCR add, so this R add means relative address. Okay, now what is relative address? Okay, so what is relative address? For this we need to go. Let us discuss this thing first. So jump relative address is an address. Suppose this is an address. So for now, forget about everything. So consider this R add as an address. So JC means jump to the relative address if the carry flag is set to 1. Okay. And similarly, this jump the relative address when the carry flag is set to 0. That is JNC relative address. Now JB B comma relative address, that is jump relative if the addressable bit is set to 1. Okay. Now addressable bit, you just remember that there are some bit addressable memory locations that has been located into the internal RAM area. Okay, so from in the internal RAM area, if particular bit is set, then the program will jump to the relative address, and similarly the opposite one, if the bit is not set, then the program will jump to the relative address. And the last one, that is a JBC, that is jump relative if the addressable bit is set to 1 and clear the addressable bit. Now simultaneously this JBC do two tasks. Number one, jump relative if the particular bit is set to 1, and parallelly it will clear this particular addressable bit that is located in the internal RAM address. Okay, so this was the example of bit jump. So there are examples of byte jump and unconditional jump also. So we are just going through. Just hold. Let's do this quickly. So after recording, you can leave the class. Thank you. Thank you so much.
Thank you, sir.